Yeah, so I guess that this is a nice dovetail to what David was talking about in terms of what you can do with Lambda in the 2021. So I should probably start by just saying, defining what do I mean when I say serverless, because ever since Lambda was launched in the 2014, serverless became a thing, and every time I mention serverless, someone reminds me there's still a server somewhere, which of course is just missing the point. And I think Graphql says it best when he says that the serverless is serverless in the same way that the Wi-Fi is wireless. Even though you still got cables running around, well, guess what? Those cables are not your concerns when you want to connect to a Wi-Fi connection. So when I think serverless, I really think anything that where any technology that meets a number of criteria, such as you don't pay for it when no one's using it, you don't have to worry about scaling, you don't have to worry about managing and provisioning those servers yourself. You get a lot of that benefits out of the box because you're using a managed service. So, I guess by this definition, is when I say serverless, it's not just I'm not just talking about Lambda. I'm talking about other services that fit this criteria, like DynamoDB, like S3, like SQS, like SNS, and so on. And I think serverless is, in many ways, is kind of very similar to the evolution we had in terms of driving and how we used to have to manage a car ourselves. We used to have to, I guess, do MOT services on those cars, and then now we can just rent a car and we can, or take a public transport where we only have to worry about figuring out how we're going to get to where we want to be able to just take out our phone and hail Uber or Lyft. So when it comes to serverless, I'm thinking, okay, we used to have to manage servers, and then we get to the point where we can just rent servers from a cloud provider. So we can actually, we can do a pretty good job of virtualizing or encapsulating that configuration for a server and run them as containers. So we abstract away another layer of the infrastructure to when it comes to serverless, you just write the code that you want to ship, and you don't have to worry about how it's hosted, how it's run, how it scales, at least for the most part. In some cases, you do have to worry about them. But for the most part, you just focus on writing the code that you actually want to run, as opposed to all the infrastructures around it. And so you've got, I guess, in terms of paradigms, you've got a more sort of serviceful as opposed to serverful infrastructure where you use a lot more managed services. And you have also to get this pay-as-you-go payment model, which is very important when you get to the point where you want to make smart decisions about which part of your application you want to, say, optimize to save cost. If you know how much individual functions are running and how much individual functions are costing you, then you can make a smarter decision about, okay, I've got infrastructure that's got 2,000 Lambda functions, but only 5 of them gets run often enough, and that a lot of the cost is centered around those couple of functions, then I know where to optimize rather than trying to do a broad stroke and optimize everything based on the guess. So when it comes to Lambda, you write your little handler function, you upload to the cloud, to AWS, and then you configure AWS to say when your function should run. Maybe when someone makes a request to your API, maybe when an IoT service, a device has a publisher event that you want to handle. And in this case, you've got something that's auto-scaled based on traffic. So more traffic comes in, more workers get spawned to run your function. And equally, when all the traffic goes away, well, all the workers gets the garbage collected, so it scales to 0 as well. And the great thing is that you don't have to pay for those idle resources you've got sitting around not doing anything. Like if you look into your EC2 cluster, you may find 1 or 2 of those servers that just runs once every day to run some cron job. Those are perfect examples of things that you're paying for a lot of idle time. And also with Lambda and other similar services like API Gateway and DynamoDB, you also get multi-AZ out of the box as well, which gives you very good baseline redundancy so that if there's a problem with one availability zone, your application is largely unaffected. And when a request comes in, you have a built-in load balancing if you're using services like API Gateway. And you can, in this case, you don't have to worry about the routing traffic to different availability zones. You get it out of the box. And quite a common combination of building REST APIs is to use API Gateway, Lambda and then using DynamDB behind the scenes. And in this case, you can see that I've just switched from having 3 different availability zones inside US East 1 to having different regions. And the great thing with using DynamDB is that you get the global tables, so you get global replication out of the box with just a few configuration, rather than having to implement all of that replication logic yourself. So in this case, it's quite trivial for you to build a multi-region active application whereby you have the same API deployed to different regions. And so when and then you front that API using Route 53, so that when a user comes from, say, US, you route them to the US regions. And if a user comes in for a mixed request from Ireland, then they get routed to the Ireland region. And all the data changes are globally replicated across the different other regions, because that's just where you get out of the box with DynamDB global tables. As to why serverless, for one thing, it's really scalable out of the box. You don't have to wait for EC2 instances to get spawned up, and then you can also just tap into a massive pool of available virtual machines that Amazon Lambda team is managing for you. And there's some limits around the scaling. We will talk more about that later. But by and large, for most use cases, you can tap into a massive pool of resources that is available to you on demand. And you don't have to pay for those resources when you don't need them. Lambda, for a lot of your workloads, is going to work out a lot cheaper, at least overall. Of course, it depends on context. So some APIs, really high throughput APIs, you may find that it will still be a lot cheaper if you run it on the, say, containers or on EC2 instances at a super high scale, that is. But you also get, like I said, you get a lot of redundancy out of the box. And also the fact that you don't have to secure the OS yourself removes a massive layer of security and vulnerability from your application. You don't have to worry about securing the OS, the Docker images, the networking, all of that. And Amazon will do all of that for you, which is, let's be honest, they can do a much better job than most people like myself can do in terms of securing the OS and making sure that everything is up to date all the time. But I think that, I guess that's maybe really sort of stick with serverless once I start working with it, is the fact that from before, where to go from having an idea to having something running in production, there's just a lot of things you got to decide. You have to make decisions around load balancing, configuring AMIs, capacity planning, and all of that. And when it comes to using Lambda, most of this becomes either trivial or irrelevant. And using tools like Server Framework, your deployment becomes super simple. So in return, you get this super highway between having an idea to actually having something in production, so they can start testing against the market. And I know this because I've done this multiple times now. Most recently, I did a project with a client where we built a new social network using GraphQL and AppSync and Lambda in the backend in just a couple of weeks, just working on myself as one-man band on the backend side of things. And I can do that because I'm able to basically minimize the amount of undifferentiated heavy lifting. Anytime I'm spending time to manage infrastructures, that's doing something that is not going to differentiate the product from anything else. Customers don't care how well we manage our infrastructure. They just care about having something that works, something that scales, something that's reliable. And once the system's live, I've got less operational responsibilities on my shoulders as well, which again allows me to spend more time focusing on actually delivering value to our customers. So my name's Yan. I've been working with AWS for well over 10 years now. Since 2018, I'm also one of the serverless heroes as well. And one of the things I've done, one of my first projects working with serverless technologies was about 2015, 2016, when I migrated another social network to run pretty much entirely on serverless. Nowadays, I work half of my time as a developer advocate with Lumigo, which is a troubleshooting platform for serverless applications, which makes some of the things that David mentioned before, and that can be challenging in terms of having a more asynchronous flows using SNS, EventBridge, Lambda, and actually figure out what happened when you get an error in your stack somewhere and try to link everything together. The other half of my time, I work as an independent consultant, where I help companies all around the world adopt serverless and go faster for less. In my spare time, I've written a few books, and I've also got a podcast where I speak with other people that build systems using serverless, and I released a video course called the AppSync Masterclass, where I show, I guess, how you can build systems really quickly using AppSync, Graphql, and Lambda, and so on. So back to the topic of what I want to talk about in terms of what you can do with Lambda in the 2021. You've already seen this. I showed this earlier in terms of a very common use case for building REST APIs using Lambda, API Gateway, and DynamoDB. So in terms of API Gateway itself, you actually have two flavors of APIs you can build. You have the REST APIs, which is, I guess, version 1 of API Gateway. And then you have version 2, which is called, confusingly, HTTP APIs. So it's not super Google friendly when you want to search for them. The big difference and the big reason why you want to go to HTTP APIs if you can is the fact that it's a lot cheaper compared to API Gateway. What I find is that at scale, a lot of the cost for high throughput APIs when that uses serverless components is heavily tilted towards the cost for API Gateway. So if you can use HTTP APIs, that will help cut down the cost for API Gateway massively. In terms of feature set, there's still a few things that the HTTP API doesn't support yet, but by and large, most of the things that you had with API Gateway REST APIs are now supported on the HTTP APIs, and you get massive cost saving for using HTTP APIs. But you can also use ALBs with Lambda as well, which I think when it comes to ALBs is a little bit tricky. There's the hourly charge for having ALB. But then in terms of the cost is calculated by number of load balancer capacity units, or LCUs, which is based on a number of different factors that's average over an hour. And if you look at something, say, if you look at an API that's doing, say, 1 request per second, averaging 200 milliseconds, and then processing 1 kilobyte of data. So over the course of a month, this is kind of the guesstimate, guesstimate for the cost for the different options we have here: API Gateway REST APIs versus HTTP APIs versus ALB. So when you have really low throughput, anything that's cost you like a base, hourly rate for uptime is probably going to look a bit more expensive on paper. But as you scale to a really high throughput, then you can work out, okay, suppose we have a system that does 1,000 requests per second on ALB. This is the calculation that allowed me to arrive at, I guess, a rough estimate of 40 LCUs that we're going to need for this load balancer. And so at that cost point, you can see that for something that handles 1,000 requests per second consistently throughout the whole month, API Gateway can be order of magnitude more expensive compared to using ALBs. And this is one of the lessons that quite a few people have found using, I guess, the API Gateway and Lambda and DynamoDB for high throughput system, whereby they find at the end of the month that the cost for API Gateway is pretty significant. And so this is one of the areas where you can save yourself a lot of money by just moving to ALB, provided that all the features that you're looking for is supported on ALB. And I think as a rule of thumb, if you've got a high throughput requirement for your API or for your application, then you want to use services on AWS that you can pay by the hour, because they're typically orders of magnitude cheaper when you're running at scale. But of course, that is only when you're running at scale. There's other things that the ALB does, which the API Gateway doesn't do quite well. So API Gateway supports canary deploys and all of that, but its canaries, its channels is based on traffic routing. There's no stickiness. So if you've got like a paginated request, then the user is going to be jumping between different versions, can jump between different versions, between different page requests. And ALB has ALB's canary deployment supports stickiness, so you can tie a user to the canary channel, so that you remove the whole jumping around. In terms of cold starts, oftentimes you want, for APIs that are user facing, you want to have a predictable latency. And one of the questions around Lambda is that, what about Lambda cold starts? Like David mentioned, cold starts has gotten a lot better over the last couple of years. AWS has continued to improve the platform under the hood to improve the performance of cold starts. But first and foremost, I think you have to think about what is your latency requirement and what languages you're using and how you're writing your Lambda functions make a big difference. And when it comes to cold starts, you can think of cold starts in terms of both frequency, how often they happen, but also in terms of duration. If you can get the duration down to within acceptable latency range, so that even when cold starts happen, they still take what 500, 600 milliseconds to run. Then and your say P99, your SLA is 1 second. Then you're still within acceptable latency range without having to look for ways to keep your functions warm and to try to reduce the frequency of those cold starts. In cases where you can't optimize your function anymore, then you possibly can, and you have to use languages like Java or .NET Core, which has got worse cold start performance because of the fact that you got a whole VM that needs to get boot up every single time a new worker is created. Then look at provision concurrency, which allows you to essentially have a warm workers for Lambda functions running all the time, and you have to pay a premium for that. But if you can make enough usage of that, those provision concurrency, and I calculate it to be about 60 to 70%, then you can actually find that the Lambda functions are cheaper when you run them as with provision concurrency than the default on-demand concurrency. So that's probably one of the most popular use cases I've seen people using Lambda, which is to build REST APIs. And closely related to that, well, what if you want to have a WebSockets instead of REST APIs? There's actually quite a few different options available to you here. You got API Gateway, which had the support for WebSockets since about 2018. The way it works is kind of low level though. So whenever a user connects to a WebSockets API on API Gateway, you have to handle the onConnect event with a Lambda function. And you're going to get the connection ID and all of that. And so you have to manage and keep track of the ID yourself. And so when the user disconnects, you have to handle the onDisconnect event with another Lambda function that again have to remove the connection ID from your database somewhere, so that when you want to send a message to users that are connected to the WebSocket WebSockets API, you're going to have, say, a Lambda function, look at the connections in DynamoDB, get the IDs that you need to send the message to, and then for each connection, call API Gateways, one of these management APIs to say, please send this message to this connection, and here's the connection ID. Which, as you can see, is just a very low-level construct where you have to manage the connection mapping yourself. So if you put in like a chat application where you got chat rooms and groups and stuff like that, it's up to you to create that mapping between the connection IDs and the group IDs or chat room IDs that you want to send messages to, because there's no built-in way to do broadcasts. And so if you want to broadcast a message to everyone who's connected, then, well, good luck, because now you have to basically get all the connection IDs from your database, and then for every single one of them, send a request to API Gateway to say, hey, please send a message to this connection, which, as you can imagine, is just not efficient and not performant, and can get expensive quickly as well. And then you've got AppSync, which is the kind of manage the GraphQL as a service on AWS. And one of the things that they added support for was the native WebSockets connections on AppSync. And so, as part of that launch blog post, they talk about how they were able to scale it to 10 million connections on the AppSync WebSockets connection. So it's pretty scalable stuff. And the way it works is all tied up with the GraphQL's subscriptions. So you can have a subscription type that defines the different updates that you want to be able to push to the client, and so the client can subscribe to those. And that's it. Pretty much, you just connect the mutations that you want to return the updates that you want to send to the caller, and the caller just have to connect to the different events they want to listen to, and you get broadcast and everything out of the box. So it's very scalable, very easy to use, but it's all tied up with GraphQL, and you kind of have to use GraphQL at least for the subscription part to use the AppSync and the WebSockets. And then lastly, they also have support for WebSockets on IoT Core, which is a service that is actually not just for IoT. In fact, the whole set of a lot of the services in the IoT sort of category can be used for other things. And IoT Core really is just a MQTT with a rule engine that can run over WebSocket protocol. So you can use, you can have, say, applications that connect to IoT Core, and then get updates from your application via WebSockets in the MQTT protocol. So for this to work, your client application have to connect to IoT Core. You have to sign the request using Amazon's signature V4 signing format. And the messages that you receive are going to be tied up in the MQTT format. So they're not the sort of raw messages you're going to get via WebSockets. It's all going to be wrapped inside an MQTT message. But still, those are some of the options you have in terms of building WebSockets, which we are seeing more and more people adopt because it's a very nice way to build real-time applications easily without having to manage any infrastructures yourself. So I mentioned GraphQL. So if you want to build GraphQL APIs instead of REST APIs, then you've got AppSync, which can act as manage the GraphQL server that is able to that lets you write resolvers that connects to Lambda, DynamoDB, RDS, Elasticsearch, as well as to any REST HTTP endpoints that you have. So AppSync itself is very scalable. It's multi-AZ out of the box, like out of the serverless technologies on AWS. And you only pay for what you use as well. The cost is $4 per million operations, which is on paper a lot more expensive compared to API gateway, especially compared to HTTP APIs. But if you consider the fact that with REST, you've got this N+1 request problem where you often have to, say, to render a single UI page, you have to make multiple requests. Whereas with GraphQL, you can probably encapsulate everything you need for a single UI page into one GraphQL operation, which means that in total, you might actually end up being cheaper running your API on AppSync just because of the fact that you need fewer operations compared to REST. And then you've got support for built-in caching, which is a common problem for GraphQL applications where you've got a single entry point for your entire API, which is not that easy to cache using things like CloudFront. So AppSync kind of solves that particular problem for you out of the box. And you also got built-in integration with CloudWatch and CloudWatch logs, so you get a lot of the metrics and logs out of the box. And you get all of this without having to manage any infrastructure yourself, which is pretty great. And it's been my favorite stack, I guess, when it comes to building new applications for both mobile and for web. So that's GraphQL APIs, the tick. What other things can people do? Well, there's a lot of data, I guess, data science, machine learning kind of pipelines out there. So implementing data pipelines with using serverless components is also a very popular thing, where you can use tools like Kinesis and Lambda to basically ingest a large amount of data. And so quite a while back, I spoke with Anahit, who's the engineer for Wiley, which is the national broadcast company, national broadcaster in Finland. And their APIs and the data pipeline ingest something like 500 million events per day at a peak of something like 200,000 requests per second. So all that event is going through Kinesis and batched and processed by Lambda functions at a pretty big scale. And they use a combination of Kinesis data streams, Kinesis file host streams, and then putting data into S3 as a data lake, and using things like Athena to do some of the querying at scale. But they also use Kinesis analytics as well, so that they can run a real-time aggregation on those events before using those events to trigger Lambda functions. And then to sort of reward their machine learning models. They got a bunch of personalization models. With Kinesis Analytics, you can also output them to another file host stream as well, which can then allow you to buffer and batch the data and save them into S3 or some other data lake that you want to use instead. So with Kinesis, there's a lot of flexibility of what you can do, and at scale is also very, very cost efficient as well. AWS actually under the hood uses Kinesis for collecting all the information that they need to build you for every single request and for everything you're doing. So that gives you a sense in terms of how scalable Kinesis is as a service. So in terms of big data pipelines, data projects, this is Lambda and Kinesis is very, very popular. What about in terms of like things like DevOps? There's a lot of, you find a lot of cron jobs and things like that, which again, with Lambda, this becomes super easy. You can set up I guess some kind of like execution cron job using CloudWatch or EventBridge, setting up a new EventBridge pattern that runs every so often, and then that triggers a Lambda function. And so that Lambda function can then do a bunch of things when it runs, and then when it doesn't run, you don't have to pay for it, you don't have to think about it. And then another thing you could do with EventBridge patterns and Lambda is that, well, anything that's happening in your AWS environment, if you got the CloudTrail enabled, everything's going to get collected by AWS and recorded by CloudTrail, and you can basically use that to trigger any number of automations you want to do by creating an event pattern in the EventBridge, and then looking for the specific events that are happening in your environment, and use that to trigger Lambda functions. So, for example, whenever I see someone creates a new log group in CloudWatch logs, I want to do some automation to update the retention policy and things like that the retention policy on the logs data, which by default doesn't expire, by the way, which is usually not what you want for logs data, because you're going to be paying more and more every month. I can have this pattern and then use that to trigger a Lambda function and say, you know what, I'm going to just update whenever a new log group is created, I'm going to do something else. Or whenever an EC2 instance has been terminated, I'm going to clean up some resources and whatnot. You can also connect the CloudTrail and EventBridge with Lambda using AWS config, so that you can write custom config rules with Lambda functions, so that you can check configurations for AWS services and then automatically remediate whenever there's a non-compliance, when there's a non-compliant AWS resource has been captured and flagged by AWS config. So again, you can do that using AWS config, EventBridge, and Lambda. So when it comes to DevOps and the DevSecOps, there's a lot of things there's a lot of automations you can do using Lambda. In terms of things like, what if you've got like a complex business workflow, which things like processing orders and a bunch of other things like that, you can capture those business workflows and model them as state machines inside a step function, which is an orchestration service that allows you to model your workflows as state machines using JSON, but they also now support a YAML language as well, language format that basically says, okay, here's my state machine, there's the different steps, and then you can have branching strategies, you can have process data in parallel, you can have loops and a bunch of other things like that. So essentially, a state machine is, in terms of like, I guess, terminology, you can think of it as a class. And when you want to execute your state machine, think of it as like instance of your class. And for every execution, you need to give it some input. So those are the arguments that you pass into, say, calling a function. So you can start a state machine using just API calls with AWS SDK, using the CLI, but you can also trigger state machines workflows using API Gateway or using EventBridge as well. So you can automatically trigger event workflows using cron jobs or using some events that connects to things that are happening inside your AWS environment. So in terms of writing step functions using serverless components, there's a serverless step functions plugin which allows you to do that using the server framework. And the nice thing with step functions is that once the execution started, you can see the different flow, the different path that it took for particular execution, and where it succeeded and where it failed. And for individual steps, you can see the input and output as well. So it makes debugging super easy. A lot of these steps may be implemented using Lambda functions. So you can also use the step functions execution history to find out what are the functions that ran, what was the outcome, and you can also quickly access the logs for those functions as well. So one thing to keep in mind when it comes to step functions is that it's one of the more expensive services in AWS, and the way it charges you is based on a number of state transitions And every single one of those boxes that an execution actually goes through is called a state transition, including the start and the end. And the way I guess the price is $25 per million, which is significantly higher, I find, to be compared to the Lambda costs. So I guess in response to this common complaint people have in terms of step functions being expensive, AWS released I guess a different variant or different taste, a flavor of step functions called the Express Workflows, which has a limit on how long your state machine can run for, with 5 minutes, whereas the normal state machine executions can run for up to a year. But this variant is much cheaper, and they charge based on execution time as opposed to number of state transitions. So there's a lot of companies that are using step functions at scale, companies like Coca-Cola, iRobot, 20th Century Fox, and Disney, and so on. So a lot of very well-known companies that are using step functions with Lambda. If you want to learn more about step functions, I also got a video course you can check out as well. So that's if you want to learn how to do business workflows and model them using step functions and Lambda. I guess in the early days, one of the common use cases is video encoding. This is probably one of the earlier use cases I found with Lambda, actually, which still some people do. Companies like Cloud Guru, for example, they do this, where you can put some video files into S3 bucket that triggers a Lambda functions, and then you can use elemental services like Media Convert to convert the video into the right format and so on, and then output them into some other file. A common problem you run into with this particular domain is that services like Media Convert would take as long as in terms of time to process a video as the video itself. So if you want to have something that can do a lot quicker, then you find a lot of people use this approach, whereby they again use S3 to trigger Lambda function whenever the raw video footage is put into S3, and then they use that to trigger a step function's state machine, which you can then trigger a Lambda function to use FFmpeg to split the video and into many smaller chunks. And one of the nice things you get out of the box with step functions is that you can use that map state that take in an array and then process individual elements inside that array in parallel using different instances of a Lambda function. So these are the same Lambda function, but many instances of it running in parallel. And those functions can then use the FFmpeg to process and convert individual fragments of your video, and then return some output, which will be, put into S3, and then there'll be a pointer to where that fragment file is in S3. And the map state actually collects the output from the individual outputs from the initial input array, put them back into an array with the matching position for the elements. So it then can be passed along to another Lambda function, which is going to use FFmpeg to stitch together all the converted fragments and then write it to the output. So this is exactly what some of the companies are doing, such as Thomson Reuters, to speed up the video encoding process, which when they did this, the average processing time went from 20 minutes to 2 minutes by just doing it with a parallelism of 10. But they can actually push it a lot further if they just use a more concurrent Lambda functions to process them. So again, quite a common use case, but for specific, I guess, industry more. But then there's also, this, I guess, but then the other cases where I guess more applicable to many more people would be how do I build an event-driven system? What do I use as event bus inside AWS? Nowadays, you should be using EventBridge instead of SNS and SQS, or some combination of SNS and SQS. And the reason for that is that with EventBridge, you have a lot more targets to begin with. You can target many services compared to SNS, which can only hit a few different things. You get out of the box with EventBridge as well is the schema discovery and the schema registry, which can actually create custom registry yourself, so that if you got an environment where lots of different teams are publishing events to your centralized event bus, and you want to have some common registries to keep track of all the different schemas for events, you can actually create a custom schema registry in the EventBridge, and then you can push those schemas files from your application to that as well. And The big thing though you get with EventBridge that SNS doesn't have is you can do content-based filtering, which is one of the things that you can't do with a SNS. That makes it not suitable for having like a centralized event bus, because ultimately the publisher and the consumer of the event have to agree on what attributes are included in the messages in SNS, because you can only subscribe and filter based on message attributes. Whereas with EventBridge, there's less concern of that. If I just publish everything as include fat events, or have more granular, smaller events, and then followed by some roll-up event, then my subscribers can just do their own thing. They just look at the content that's available to them based on the schemas they find in the schema registry, and then just do their own thing without having to keep bothering the publisher to include additional fields in the message attributes. And we saw earlier as well with EventBridge, you can also use that for cron jobs, and you get to do a lot of automation, because you also collect a lot of events from AWS in terms of what's happening inside your AWS environment. But you can also use EventBridge to ingest third-party events, like you want to react to something happening in Salesforce, or when user log in and log out of Xero, so that you have some audit trail that you want to process or just keep track of in your AWS accounts. Because you can also have archiving available in the EventBridge now as well. Or for your application, you got different microservices. They want to publish events to EventBridge to a centralized event bus. And then you can have subscribers that listen to those events and then do their own thing. And maybe they want to also publish their own events back to the event bus and things like that. So you can create a really nice ecosystem of a highly event-driven application using Lambda and the EventBridge. So one common thing one thing you've got to think about though, if you want to do that, is how do you handle failures? You can set up a delta queue in Lambda, but delta queues they only capture the payload, not the error that caused your function to fail. With async invocations, like from EventBridge to Lambda, you get 2 retries out of the box, which is great. But if after 2 retries your function still fails, you want to capture the payload and ideally what actually happened, so that you don't have to go to the logs and figure it out after the fact to see what you should do with this event. So I forgot when it was, I guess 2 years ago, Lambda introduced this notion of destinations, which is another way to do a delta queue, I guess. So in this case, with failure destination, Lambda will capture both the payload and the exception for the last retry, so that you have everything in one place. So in this case, you get the request context, and more importantly, down below as well, you get the response context, and in the case of a failure, you get the error exception captured in the same payload as well. And you can also use I'll come to that in a minute. So when you enable Lambda destinations, you see in the monitoring tab in the Lambda console, you got some additional metrics for delta errors as well as destination delivery failure. So you want to set up alerts around this, so that if there's some problem from Lambda to when you try to deliver those destination error messages to say SQSQ that you've configured as your your failure destination, then you want to find out. You do get retries, I think, for a couple of days, something like that. But if you don't have any alerts, you don't know this is happening, then you can still end up losing events. And also compared to normal DLQs, which can only work with async invocations and doesn't work with streams, destinations actually works with streams as well as async invocations. And also it supports more targets as well. So nowadays, you should know, if you want to you want to set up a DLQ for your function, and you should, when you're doing async event processing, you should use the destinations instead of the normal async DLQ instead. You can also use the destinations for successful async invocations as well. So this could be useful if you're doing something and you have a very simple workflow where you just want to trigger something else. So instead of you having to call another Lambda function yourself, this can basically just do it for you. And I think this is only useful and only suitable for really, really simple cases where you've got literally just a one-hop workflow. Anything more than that, you should use the step functions. But for those really simple use cases, step functions might be a little bit overkill, which is why this can still be useful in those specific cases. But yeah, more complex use cases, more complex the workflows, go to step functions instead. The last two I want to quickly go over because I haven't done it myself is Alexa skills. There's a huge market of Alexa skills that you can that's out there. You can write Alexa skills yourself using Lambda functions. And then there's also IoT devices. If you're building IoT services, then like iRobot, for example, you will use IoT core with Lambda to process those events at large. And iRobot is doing this, is running a fully serverless backend for all the millions and millions of robots they have out there. And one of the reasons they give you, that they do that is because for them it's a massive cost saving. And it's a big competitive advantage for them because they charge you for the robots, but not for the services that they offer afterwards. So they want to minimize the cost that they need to incur to deliver those services to your robots as much as possible, and which is why serverless for them is a big win. And also why they don't talk about that the cost aspect of their use of serverless quite as much, because for them it's actually a business advantage that other competitors are maybe not caught on to the idea of serverless just yet. So yeah, those are just 10 use cases. There's a lot more where this comes from, and I'm seeing people adopt serverless for all kind of different workloads nowadays. And the good question would be, well, that's all great, but when is the serverless not the right choice? I think it's just the main thing I would look at is looking at your non-functional requirements. For example, what is your scaling requirement and what is your performance requirement? With Lambda, you still have some scaling limits. You can go from 0 to 3,000 concurrent executions with no warning like that, which is great. But if you need to go from say 0 to say 10,000 concurrent executions because maybe you're building a live sporting event. My last full-time job, I was working for the Zone, where we had spikes of going from a couple hundred users to 1.7 million or something like that. So the spikes are too steep even for Lambda, because once you hit to 3,000, you can go further. There's no upper limit on the maximum number of concurrent executions you can have. But after 3,000, you can only go up by 500 more concurrent executions per minute, which means that if you got traffic spikes that are going from 0 to 1.7 million in 30 seconds, then that is still not going to be a good fit. There are ways around it, but by the time you invest effort into making that work with Lambda, you're much better off to just run some APIs on that particular path on Fargate or something like that, where you have a more natural way to just scale it because when those traffic spikes are going to come is when Man United versus Liverpool is going to kick off or something like that. And then there's also performance requirements as well. So with Lambda, you still get the cold starts. We talk about how you could improve your cold starts so that they fall within acceptable latency range. But there are applications out there like, I don't know, real-time gaming, where the latency requirements so strict that even if you reduce cold starts to a very small percentage of invocations, that is still not going to be good enough. Then maybe Lambda is not a good fit for those because you need a bit more control around the scaling and performance characteristics of your platform. And also, when you have something that's really high throughput, you may also find that running stuff using serverless components is just more expensive than running a bunch of containers. But for that, though, you want to look at not just the cost of your AWS bill, but also look at the total cost of ownership. Because when it comes to looking at your application, the things that we tend to focus on is on the operational cost, the servers and networking, the storage and databases, even though most of our cost is actually on staffing. Like engineers are not cheap, they're getting more and more expensive, which is good news for us. But as a business, as someone who had to manage a budget, staffing cost is far outweighs operational cost in most cases. And AWS did a case study a while back. They published it, I think that was 2018, and they found that for most enterprises, there's a huge savings out there by moving to serverless, because you just need fewer people to get the same output. because to deliver the same things, because you get a lot of scaling, you get a lot of the resilience and robustness out of the box. And also, when you don't have to worry about quite as much infrastructure overhead, then that means there's less operational overhead for your team as well. But sometimes you find that for some applications that the cost of infrastructure is just much more than the cost of the staffing. Then in which case, fine, you should probably move those to containers where you can optimize a lot more in terms of your infrastructure cost. But the model that most of us advocate towards is not serverless only or containers only, but it's you should start with serverless. If something can be built with serverless, then you should start there. Until such a point that the server is no longer a good fit, then you move them into containers. And that kind of brings me to the end of my session. I know I've kind of overrun it a bit, but yeah, as I mentioned earlier, I work as a consultant. So if you want to find out how we can work together, then go to theburningmonk.com to see what I offer. And check out my video course on AppSync Masterclass, where I teach you how to build a Twitter clone using Graphql, AppSync, Lambda, and DynamDB. And so with that, I guess thank you guys very much for your time, and I guess stay safe in these COVID times. And yeah, hopefully I see you guys in person sometime soon.